This is the best 3D printer that you can build or buy for $750. It's got a Slice Engineering Mosquito Hotend that gets up to 350 degrees with a hardened nozzle that can print carbon fiber impregnated materials, and it prints nylon onto this Garolite bed without part peeling up off the bed, without getting that dreaded, drift that we see like that. So we're gonna back up in time, pick up this project right where I began it, and I'll show you guys exactly how I built this phenomenal machine. The Ender 3 is the most popular, best-selling 3D printer in the world for good reason. Now, you might think that reason is because it only costs $160, and that's certainly a big part of the reason, but it's been for sale for as high as like $260 in the past. So there were certainly less expensive printers on the market. Why did this one become dominant? The answer is because it nails it as far as the frame and motion system goes, right? The V-groove aluminum extrusions and the pulleys, the plastic pulley wheels that ride in those V-grooves is a technique which Creality learned from Open Builds, and you can certainly go on the Open Builds website and buy all the frame making material that you want to build your own printer, but it's very difficult as a DIYer to precisely cut, drill, and tap the holes in your frame stock. So being able to buy a printer from China that's already made with that same technique, the Open Builds technique, is really desirable, and they've nailed it. They've really done a great job. Not only that, they sort of pared it down and removed everything superfluous, including the second lead screw and stepper motor. So you only have one Z-axis lead screw and stepper motor, which actually functions perfectly because of this short X gantry. So they've just really nailed it, and that's why the Ender 3 is so good. Now, it comes shipped with a rock bottom Melzi 2.0 derivative control board, just as cheap as you could possibly make a control board for a 3D printer. So there's something that needs to go right off the bat. Also, the Hotend it does a pretty good job, but you have to do Luke Hatfield's upgrade to that Hotend if you really want to make it fully functional. So those are the three major components of a 3D printer: a solid frame and motion system, a fantastic control board, and a great Hotend. So what you're looking at here is the Ender 3 Evolution, and this is the culmination of all of my work. So all of the printers that you guys have seen me review and upgrade on this channel, this is what I think most people should be building, because it's the least amount of money for the most functional printer that you can possibly get. So go ahead and watch the video here. I'm not going to get into it too much on this video because why cover things twice? But yeah, the Ender 3 Evolution is just the most printer for the least amount of money. The thing it's lacking is a good Hotend. I kept the stock Hotend because, like I said, it performs pretty well. So today, what we're going to do is add the Slice Engineering Mosquito Hotend to this printer. And at $250, this Hotend is the most expensive component on the printer by far, more expensive than the whole motion system and the control board. Let's get into it. These pieces here are the core of today's upgrade. So these are what's going to allow us to adapt the Mosquito Hotend that came in this box onto the printer here. So everything else largely going to stay the same about this. We're going to change up the bed. But yeah, this is the core of it, and let's go over this. So these parts here were printed out of carbon fiber impregnated PETG, which is my favorite material to print with. It's strong, it's stiff, and it's reasonably temperature resistant, and you can print with it with any printer, pretty much any printer, as long as you add a hardened nozzle. So these are some cheap, $3 hardened steel nozzles coming from China, and that's pretty much all you need. But you can print with a brass nozzle if you want to. It's just that you're going to wear out the nozzle. So after you do a couple of print jobs, you just have to replace the nozzle. Not tragic. So yeah, I really like this material, but it's not as temperature resistant as it could be. Even ABS is more temperature resistant than this. So I've printed the fan duct here. This is the split part cooling, and I've printed that out of polycarbonate because I have the ability to print that with one of my more fancy printers. And polycarbonate is going to be a very high temperature plastic. It prints at 310 degrees. So it's going to be resistant to the heat from the Mosquito Hotend hot block there. But you could do this with ABS if you don't have that ability to print with this yet. However, you could do the rest of this upgrade right here with the Mosquito Hotend, including the high temperature ability, and you don't need a part cooling fan to print this component. So after you've done most of the upgrade, you could do just the part cooling portion of this design. So pretty cool there. And these green pieces of filament are a neat little trick that this design has up its sleeve, and we'll get to that later on. You can probably guess what I can do there. But yeah, so this is the mock-up of the components printed out of PLA just for fitment, real rapid print there just to see if everything was going to work. And it is, except that you can see I'm getting collision right there. You see that collision? So the aluminum there for the pulley wheel has to get a V bird's mouth cut out of it so that the hot end can not touch there. So it needs to swing down a little. You can see the gap right there in the adapter. So that's what needs to happen. That's the only kind of big thing. Other than that, it's all just kind of bolt screw on components, and it should all just work. You can see I've filed that bird's mouth out of the part now. So that's what it looks like. And I've got all the clearance I need. No issues with strength. That's plenty strong for this 3D printer. So yeah, you're gonna have to cut and file a little if you're gonna do this upgrade yourself. There's no way around it. I wanted to keep the original location of the nozzle. So that point on the nozzle is in the exact same position as it was with the stock Ender 3. So now I just need to get it all mounted to the printer. All right, the physical installation is complete. All that's left to do is to take this wire here, which goes to this end, and this is the new high temperature thermistor from Slice Engineering. So this will allow me to get the temperature of the nozzle here up to 350 degrees. So I'll be able to print polycarbonate on this printer here in a few minutes. So I'm just going to attach this wire, or these two wires I should say, to the duet board inside of the case here, and these attach to the exact same spot as the stock thermistor. And it's an easy thing. You just got to change a little value in firmware, and Bob's your uncle will be done. So let's get that done. Now I'm not going to show you any of the wiring here in this video. There's a dedicated video for wiring up the Ender 3 with a duet board. Look for the playlist of those Ender 3 videos in the description down below. So if you want to learn how to do the wiring, but it's a really quick and simple job. So let's do that, and then let's jump into firmware. For anybody who doesn't know what makes duet control boards so special and absolutely worth every penny, you're looking at a major reason why. That's a website. That's all it is. It's just a web page. Any device with internet access, like a cell phone or a tablet or a Macintosh or a PC or a Linux computer, any of those can open up a web page easy peasy, and you can get in there and start controlling your 3D printer, which is awesome. So we're looking at the Ender 3 Evolution. I'm connected to it. You can see the name of the Ender 3 Evolution right there. And down here in the machine specific tab, we can see that I'm running Duet firmware 2.05.1, which was the last update to Duet firmware, or RepRap firmware 2. So they've moved on to RepRap firmware 3.0. So there's a new version of the firmware out, but we'll get there in just a second. Okay, so currently I can go to my system tab here and then click on Config G and scroll down here to the heaters, and you can see I've commented out this M305 line. So the M305 is the G-code command that references the heater, right? The nozzle heater specifically. So I've changed that one by putting a comment out in front of it. A semicolon comments it so that the firmware ignores that line. And instead I've added this line above it, which is the values that are needed for the Slice Engineering thermistor. Now, that thermistor will go to 350 degrees. In a previous video, I was called how to print at 310 degrees or something like that. And I showed how to use a thermocouple with a thermocouple daughter board, a little extra PCB. So all things told, that's about $40 for the thermocouple, and the high temperature thermistor from Slice Engineering also around that same price. But you can get a high temperature thermistor from China. Quality is suspect when you get things from China. You can get one of those for like, less than $10. So I'm thinking the best solution for most of you out there, if you have an all metal hot end, so whether it's a micro Swiss or a Chinese clone or this awesome Mosquito Hotend that I put in there, any all metal hot end without the PTFE liner going all the way to the nozzle, you should be able to print higher temperature plastics. There's really no reason except that you need to change out your thermistor to read the higher temperatures. So that's what we've done here. These are the values for the Slice Engineering version. I don't know what the values there, the T, B, and C values are going to be for your made in China one, if you get one of those, but that's how you do it. You just change that singular value in the config.g. When you're done, you click save and your board will automatically refresh itself and changes will be made. So this is running perfectly. You guys, I've got no issues with it. The only tiny little micro annoyance is if I forget to load filament through the filament runout detector, the error message that pops up is blank. There's no words on it. It just says okay. But I know that that's the error message. The blank error message just means I forgot to load filament. That's the only thing that's not functional in this entire build. And they're not going to update this. This is the end of the line for RepRap firmware 2.0. They've now made and moved on to RepRap firmware 3.0. Or I don't know what they're into, 3.1.x or whatever. And it will work on your Duet 2 control boards. But it wasn't designed for the Duet 2 control board. So they're coming out, Duet is coming out with this Duet 3 Mini Plus. This is the best. I can't wait for this board. This is going to be the perfect 3D printer control board. I can't wait for this. It's basically the evolution of the Duet 2 Maestro. And they've already released, Duet has the the Duet 3, which is the big beefy one for running, like CNC machines even. Yeah, so Duet 3 is the future, hence RepRap firmware 3.0. But they've made RepRap firmware 3.0 backwards compatible. You can see it right here on the online configurator. They've made it backwards compatible to your Duet 2 Wi-Fi, or you can go with the Duet 3 or whatever it is. So, yeah, it's backwards compatible, but it wasn't really designed for it. And that means that you have to get into this IO mapping tab here in the configurator, which can be confusing. So it adds this is quite confusing actually. So it adds a level of complexity and difficulty. It's just easier to get RepRap firmware 2.0 working. So that's what I've done. You just saw it. RepRap firmware 2.0 and 2.05.1. And this firmware, along with this build, is available to my Patreon supporters. You know where it is. Now that the printer is all set up, I'm running a PID auto tuning algorithm. I'll flash the command on the screen here. Yeah, so just makes the hot end kind of get up to temperature quicker and stay at temperature without bouncing around too much. So just a good little command to run to tune up your machine. But while it's doing that, it's going to take a few minutes. I want to cut this piece of Garolite because I'm going to print out of nylon here in a few minutes. And apparently Garolite, this very special type of Garolite, is the best for printing nylon. Now this is some sort of like, I don't know, maybe it's cellulose or it's cotton or it's hemp or something inside of the plastic. So it's not what it would be, fiberglass, like you find in, what is it, G10 or G12 or something like that, the substrate to your printed circuit boards. So I will put a link in the description down below to an eBay listing for this, actually provided by a friend of the channel. So yeah, it's a good source for you to get this exact stuff. But we're gonna run it through its paces right now and see if we can get nylon, the toughest of the tough material, to get it to stick where it doesn't peel up off the bed. And in order to hold this to the aluminum bed here, we could, put a magnetic backing plate, maybe like a flexible steel plate or something like that. We could do that. Or we can use the technique of these Swiss clips. So this is the kind you may be used to seeing, same kind of the E3D sells with their, tool changing printer. And you can find this on eBay But you can also get this. Now this type right here is the type that Michael, the friend of the channel who's selling this kit, sells like this. But you're going to want to bend the smaller Swiss clips like this into the shape that you see here. And that involves kind of gently using your thumbs to bend this bow into it like you see here. But then you need to crimp this corner a lot. And because this is spring steel, which has been hardened, as you try to fold that corner in, you're highly likely to break it along that spine. So you're going to want to anneal it, and you can see the discoloration there from where I annealed this part. So hit it with a lighter, or even better yet, a propane blowtorch to get that cherry red hot, and that will stop the spring steelness of just that corner. All you need is that corner so that you can bend it a little bit more. And once it's in this shape, what you're going to be able to do is use it to hold the Garolite to the bed, just like so. All right, so in order to cut this piece of Garolite down to size to fit the bed, you got to score it a bunch until you can kind of bend it, and you can see this white line on the back. Now, you can't just score it and snap it. That does not work, but score it till you see the white line, and then score it from the backside. Should do the trick. Okay, now what we're going to do is roughen up this surface. This smooth, epoxy surface is not a good substrate for printing onto. Instead, what we want to get to is the fibers. Now, there's some sort of jute or, I don't know, linen or something inside of there, and we want the nylon to try to stick to the little microscopic hairs. So, using some 60 grit sandpaper here, I'm just going to give it a good scuff all around. And after the scuff here, I'm going to clean it off with some rubbing alcohol. And here's the print test results. This is just the Garolite without anything on it. It's just raw Garolite. This is a section of Garolite with this nanopolymer adhesive on there. You can see it is peeling pretty badly. And this right here is Garolite with just simple glue stick. Elmer's glue stick here. This is kind of old. You can see it's getting mold around the outside of it. Pretty gross. But I find that the older, harder, you can see it's more dry. So that one works better than the newer. Like that brand new, these should be the same purple color. So it gets more clear the more dry it gets. So disgusting as this is, the more dry glue stick allows me to put a more thin application onto the bed here, which I find works quite well. So maybe there's some technique where you can like chop this up and mix it with some rubbing alcohol. Something I want to try later on, just to get a perfect thin application of glue stick, not too thick. But yeah, that is certainly working. So this bed is fully cooled down, and let's just take a look here. So that's still stuck fairly well, but you can see the definite kicker right there with that peeling. This one is even worse. It's peeled all the way to the middle there. So, but it does stick. Surprisingly sticks without any glue stick. So let's take this one off now, if we can even get it off. There we go. And it's still not perfectly straight. Here, let's use the edge of Garolite here to take a look at it. You can see that there's a little bit of gap there. So it did try to peel, but the flexibility of the Garolite, of the thin Garolite here, kind of went with it. And yeah, well, that's still the best results that I've ever had. So yeah, Garolite plus glue stick for the win. And this Mosquito Hotend is performing nicely. Now, as promised, let me show you guys what the little green pieces of filament here are there to accomplish. I'll use some flush cutters here to gently pull the chunks of filament from out of their slot. There it is, all the way off. So now I have all the room around the Hotend that I could possibly need, and this can just be quickly removed for printing with higher temperature plastics that absolutely don't require part cooling, where this might get in the way. And when you do want to print with stuff that needs part cooling, you can reinstall your part cooling fan relatively quickly. There we go. And stick the little pieces of filament back on the holes, and you're good to go. Now let's talk one more time about the Garolite. So this is some pretty thin stuff. You can see real thin, really flexible. So I think that these clips are a nice stopgap, but you can see just how many of these binder clips I added to the edges. And I think if you had like 12 of these types of clips, you would be good to go. You'd have to modify all 12 to look like this though. But a more ideal solution would be to use a piece of flexible flex steel like I've got here. This currently has some, PEI on top of it, and you could certainly glue PEI on one side, or you'd use 3M adhesive. They sell these big adhesive mats. So 3M adhesive to hold the Garolite on one side and the PEI on the other side would work, except it does not work with these rubbery magnetic beds that come from China. When you put the Garolite between the flex steel and the magnet there, you just get, it moves around too easily. There are other aftermarket systems that use like neodymium magnets, so you might still be able to make a composite bed like this where it's both Garolite or PEI, depending on whatever material you're printing with. You could use either side of the bed, but this solution from China is not gonna do the job. So prices have been coming down, and what I thought was a $750 printer is in fact just a $630 printer. So let me break down what you're looking at right there. It's $200 for the Ender 3 Pro, so the upgraded version of that with the Meanwhile power supply. $155 for the Duet 2 Maestro inside of there. Now, the Maestro is purchased at Matter Hackers for that price, and the Ender 3 Pro comes from Creality3D.shop for that price. The BL Touch comes from Philistruder at $35, and the Garolite comes from the friend of the channel, Michael, there on eBay for $25. So yeah, link in the description to Michael's listing. So yeah, $630 for what you're looking at, which is still like more than $100 cheaper than that printer kit that you have to build yourself for hours and hours from that Eastern European company. So let's get the price of this printer up to $750. You can buy a Creality dual drive extruder. I showed it previously on the Ender 3 Evolution, but that was the knockoff. Nobody, and I mean nobody, should buy that knockoff. Do not make the mistake. The knockoffs are everywhere. They're all over eBay, they're all over Amazon, they're everywhere. The only place that I found for the Creality official extruder is Creality3Dofficial.com, and that's got the genuine Bondtech CNC cut gears coming from Sweden. So yeah, that's the one you want to get. That costs $40. Okay, $40 to buy a PEI flex steel bed that will stick down right here onto your Ender 3 with the magnetic bed that comes with the Ender 3 Pro, and then another $25 for just a separate spring steel sheet so that you can mount the Garolite to the spring steel sheet, which brings the total to $735. Go buy a piece of 3M adhesive all over eBay as well, and you're up to like what, $740? Still cheaper than the Eastern European company's printer, and way better functionality. Wi-Fi manipulation of your entire printer, including print status and sending prints wirelessly. You never have to walk an SD card over to it. You get the interface, it's a really clean interface on the website. You got BL Touch, you can switch out, you can change from Garolite to PEI. Just flip it and run a G29 command, and the BL Touch will do its job. So everything about this printer is useful and phenomenal, and you can't beat it. You just cannot beat it for $750. So this is the kit that everybody should be building, in my opinion, and it can, if you get the Ender 3 Pro, you learn to print with it in its stock condition, that printer can print all of the upgrades that you see on this printer. So you don't even need another printer to print the upgrades for this. So yeah, just phenomenal. And it's great. So this kit is actually going to one of my Patreon supporters. He kind of commissioned me. He wanted me to put a BL Touch, or I'm sorry, the Slice Engineering Mosquito Hotend onto the Ender 3 Evolution, because he thinks it's going to be the best printer out there. When I kind of agree, seeing what it can do with the nylon with the Garolite. So yeah, very cool. Anyway, thank you so much to my Patreon supporters, these guys that you see scrolling by here, and also a big thank you to my executive producers, these two guys there. And that'll do it for this video. Click here to watch another video that YouTube thinks you want to watch, and click here to become a Patreon supporter of this channel. By the way, I share any and all of my files that I make in the course of making these videos with my $5 Patreon supporters. So if you want the files, that's how you get them. And I'm not trying to sell files. Trolls. The trolls are always trying to say that. Where are you trying to sell files? Like, they think everything should be free because it's on the internet. Like, you know, so that's my reward to people who help me make a successful channel. And I love making videos for you guys, especially you guys who appreciate me back. So I really appreciate you. Thank you for watching. See you next time.